This one is going to be on rate of change. So what that means is that we're looking at a graph, or we're looking at a function and trying to figure out how fast it's changing from one thing to another at any given point. So we're looking at f of x equals x squared minus 1. This is the function that we are going to start off with. This is what's called the rate of change formula. This is also in your textbook. You can find it there. What it basically says is that, in a very complicated version, is that this is going to test two different points in a graph and see how fast it's changing between those 2 points. So these are the 2 points that you'd be looking at, x and x plus h. The distance between them is h. So over the time span, that's green right there, over the green time span, we're wanting to figure out what the rate of change is during there. So in our graph, the purple part is the function, purple part is f of x, and we're trying to figure out the green line, or the slope of the green line, because we're trying to figure out how fast it's changing between those two circled points, the average rate of change between those two things. As you get further along in calculus, you'll learn that as these 2 dots here, as the 2 dots that I've circled in this question, right there and there, as those two approach each other, as they get closer and closer, you'll reach an instantaneous rate of change. In other words, a graph that looked like this, an instantaneous rate of change would be however fast you happen to be moving at this one point. And that's called a derivative. And that's going to be a really important idea moving forward in calculus. But you don't have to worry about that right now. So all we're worried about is the average rate of change over a certain amount of time. So what that looks like in our problem is going to be to plug in x minus h for x. So in our original question, we had the x up here, right here. So the purple part up here is now this part down here. The x became an x plus h. That's the only thing that changed. That's this purple underlined part. And the other part that we did was we took the green section right here, and that's the full term. That's the full term. That's the same thing. Nothing's happened with that. That's just f of x. We have an f of x here, and we have an f of x here, so obviously that means that that's just going to stay the same. The important part to notice, though, is that there is a negative sign there, or a minus sign, but that's going to make the entire thing negative eventually. So now we're looking at x plus h squared minus 1 minus x squared minus 1. But we're not quite done because we still have the h here, so we need to make sure that we include that. So let's just do that fast, and we've got an h there. Okay. So this looks complicated, but it is actually going to get a lot prettier. So for instance, we can expand them out first, like that, and we'll end up with, the way that I got the purple part is that this term right here, this circled portion, that's actually just foiling this. And by foiling, I mean x plus h times x plus h. Alright? That's typically how you're going to do anything in these problems, because there's an x minus h right up here. So you're going to need to FOIL something, provided that you're dealing with any exponents. So you can do that on your own time to convince yourself that I'm right. Otherwise, you can just take my word for it, and we can move on. The negative 1 stayed there throughout the entire problem, so all of these negative 1s stayed the same, just like it stayed the same through the other side. Although it's going to change here because of this guy right here. But we'll worry about that in a second. So that's how we got our purple part, was just by multiplying out this and then throwing in the negative 1. And the green part was just by distributing the negative to these two terms. We got the negative here, and we got the negative here, which converted the minus sign into a plus. So we've got x squared plus 2x plus 2xh plus h squared minus 1, and then minus x squared plus 1. Still looks pretty messy, doesn't look like we've done a good job. But we can actually start canceling out a lot of things. We've got an x squared and a minus x squared, so let's get rid of those. Then after that, it looks like we've got a negative 1 and a plus 1, so we can get rid of those. So now we're left with 2xh plus h squared over h. So the important thing to recognize here is that those actually all have an element of h. We've got h in our 2xh term. We've got actually two h's in the h squared term, so we can get rid of one of those. I've circled the exponent because that means that we're going to lose the exponent there when we take away 1x. And there's an h in the denominator. So what the h in the denominator does is take out the factor from each of those two. That's the same thing as saying we factor out an h of here. And then we get rid of those two h's inside, and then cross out these. So that's what's going to happen. And then we can move on to this, which we can just rewrite as 2x plus h. So this is actually the answer to this problem, is that the rate of change between points x and x plus h is 2x plus h. Now, again, this doesn't seem all that important, but once you plug in things for x into h, you'll get really helpful information. So if we want to look back to our graph, if I picked 2 points for here, like for instance, let's say I picked point 1 and 3. Now, with 1 and 3, I can move on to my equation and plug in 1 and 3 here to get 2 times 1 plus 3, which equals 5. So that means that the slope of the line in our graph here should just be 5 over 1 if these points are 1 and 3. So again, the answer to this question is just 2x plus h right here. And then I just showed you afterwards one application of that moving forward that may help you. Alright, so that's rate of change in slope. All we had to do was plug in x minus h and x to the formula and then simplify to get what we got at the bottom there. Alright? Okay, that's it. You've done everything that you need to do for homework. Now I'm going to give you a worksheet during class tomorrow, and that's going to be your that's going to be something else that I'm going to check. That's what the sub is going to give you. Alright? Have a good day.